So we're now going to look at what forces can actually do to an object. You can see here I've got an old metal trolley, and if I give it a wee push, it starts to move. I've got another push, I can bring it to a stop. Now this is going back and forwards in a straight line, but the one thing I can do here by applying these pushes is to change the object's speed. I can speed it up and then slow it down, just the same way you could do by pressing or pushing on the accelerator pedal in a car, or pressing on the brake in a car. So one thing forces can do is to change the speed of an object. Another thing we can look at would be to change direction, because if I drop this ping pong ball, you can see that as it bounces, it's going down to begin with, but then the desk actually applies a force and it pushes the ball back up again. So another thing that a force can do is to actually change direction of an object. So initially it's coming down the way, the desk applies a force and the ball starts to come back up again. What's maybe not quite so obvious with the ping pong ball, but I can show a bit better with the tennis ball, is if you do apply a force to an object, you can also change its shape. So just by applying a push on the ball here, you can actually see how the ball changes shape. And that actually happens every time you hit a tennis ball with a racket. It even happens with something hard like a softball or a golf ball. It's a bit less obvious, but you can see it with slow motion photography. A golf ball will actually change shape when you hit it with a driver. Okay, so the three things a force can actually change with an object would be its shape, its direction, and its speed. So remember, a simple way to think about a force would be a push or a pull. Now, I would like to think that you would know about magnets, that if I bring two north poles of magnets together, they will actually try and push each other apart. Okay, they're trying to push apart. If I turn one of the magnets round though, so I've got north and south together, then what I get is a very definite pull. They will actually pull together. That's an example of a non-contact force. These surfaces, the ends of the magnets, aren't actually in contact with each other to apply the force. So I can push the second magnet using the first, but the two surfaces don't actually touch. These are non-contact forces. Another example of non-contact forces can be shown with these plastic rods. So if I give the rod a quick rub with a paper towel, I can actually make it electrically charged, okay, with static. If I do the same with another rod of the same plastic, I actually give these rods the same charge. And if I bring the second one close to the first one now, you can see I can actually push the first one round, okay, using the second one. The two rods do not touch. So again, this is a non-contact force. A push between the two rods which have the same charge. Now it's not just for pushes. I've now got a different type of plastic rod here. This one's nylon, right? The clear plastic one you saw earlier with acetate. And if I rub this one, it actually gives it a different charge. And here I can actually pull them around. You can see I'm actually dragging the clear plastic one round with the white nylon one. Okay, I can actually get to stop and come back the other way. Alright, so this again is an example of a non-contact force, but in this case it's a pull, not a push. So previous examples we're looking at non-contact forces, where the two objects are actually not in contact with each other, not touching each other. So a classic example of something like a contact force would actually be the sole of your shoe in contact with the floor. Okay, that applies a force. When I press or push on the brake pedal in my car, the brake pads then work against the discs to actually slow the car down, right? These are actually examples of a contact force. And we can actually show a fairly simple one here. I've got two jotters, and all I've done is I've overlapped the pages from one jotter to the next. And they do actually require a bit of a pull to actually separate them. It doesn't look much, but they do actually require a fair bit of a pull to actually get them to separate. And again, these are examples of contact forces.